Welcome to Lyceum. Today we're going to be going over some exponential rules. But before we delve into that, let's take a look at what exponents are. Exponents are a method of expressing large numbers in terms of powers. For example, x power y is basically x multiplied y times. Let's simplify that with an example. 3 squared is equal to 3 times 3. 3 multiplied 2 times, which gives us our final answer of 9. Likewise, 5 to the power of 4 is 5 multiplied 4 times, which gives us our answer of 625. Now that we have a basic understanding of what exponents are, let's delve into the exponential rules. There's 9 of them, and we'll go into each one with examples. First, let's take a look at the exponent of 0 rule. This rule states that any number to the power of 0 is always going to equal 1, be it 5 power 0 or 1000 power 0, it's always going to equal 1. Then we have the exponent of 1 rule, which is similar, but it states any number to the power of 1 always is going to equal that number itself. For example, 5 power 1 is always going to equal 5. And 1000 power 1 is always going to equal 1000. Next, the exponent product rule is x power m times x power n equals x m plus n. So if two exponents with the same base are being multiplied together, all you have to do is add the exponents. Let's look at a quick example. 2x squared times 3x cubed. That's our example right there. And for this, all we have to do is multiply the 2 and 3, which is 6. And you can see we have the same base for the exponents of x. So 6x, and then we add the exponents, 6x to the 5th power, which would be our answer. Now the exponent quotient rule is very similar, but in reverse. So if you have x to the power of m over x to the power of n, that would equal x to the power of m minus n. When you multiply, you add. When you divide, you subtract. So an example of this, we can use 5x cubed over 10x, which can be interpreted as 10x power 1 based on the exponent 1 rule. So we can cross this off, 1 and 2. So you write that down, and x cubed minus x1, so 3 minus 1 is 2. Write that in the numerator, x squared, which can just be written as x squared over 2. Next up is the exponent power of a product rule, which can be written as ab to the power of m is equal to a to the power of m and b to the power of m. So it's stating if there's a monomial, the two terms, being raised to an exponent, this exponent applies to both. So an example would be 2x squared y cubed and all that to the whole square cube. And this can be written as, so this 3 would be distributed to this 2, to this x squared, and to this y cubed. So 2 cubed, x to the 6th, you would multiply the 3 and the 2, x to the 6th, and you would multiply this 3, the exponent, and the 3, which would be y to the 9th. And this can be simplified to 8x6, y9. Next is the exponent power of a quotient rule, which is the opposite of the power of product rule. There's a over b to the power of m. We can write that as a to the power of m over b to the power of m. So if there was an example like 3x squared over 5y cubed squared, this can be written as, so we distribute. This 2 goes to a 3 and to the x squared, as well as to the 5 and the y cubed. This would become 9x, multiply the 2 and the 2, 9x to the power of 4, over 5 squared is 25, 3 times 2 is 6, so y to the 6th. Only a couple more rules to go. The exponent negative rule states that if there's a negative exponent, a to the power of negative m, you reciprocal it to take out the negative. We write it as 1 over a to the power of m. So for example, if the number was x to the power of negative 2, you can rewrite it as 1 over x squared. So now let's take a look at a little bit more complicated of an example, which would be 5x to the power of negative 2 y over 20z to the negative 5th. So you never want negative exponents. So to simplify this, let's first start from the very left. Let's cancel out the 5 and the 20. We get 1 over 4. Next, we see that we have a x to the power of negative 2 in the numerator, which is a negative exponent. So if we reciprocal it, if it's in the numerator, we bring it to the denominator. If the negative is in the denominator, we bring it to the numerator to make it positive. So we take this x to the power of negative 2 and bring it to the denominator. So we get x squared. Then we have the y. And then if we take a look at the denominator, we see that we have a z to the power of negative 5. So we reciprocal this and bring it to the numerator. Z to the 5th power. So this is the exponent negative rule. Now, the exponent fractional rule is pretty simple. It just says that if there's x to the power of m over n, if there's a fraction in the exponent, we can rewrite it as a power m, or x power m, excuse me, to the root of n. So an example might make this simpler. Let's say there's 8 to the power of 1/3. This might be complicated to solve at first glance, but when we look at it, we rewrite this as 8 power 1 to the cube root, which is equals 8 cube root, which is 2, because 2 times 2 times 2 is 8. That's the exponent fractional rule. Last but not least, we have the exponent power rule. So if there's x to the power of m and all that to the power of n, the rule is that we can just multiply the exponents. So if there's x squared to the whole cubed, all we have to do is multiply the exponents 2 times 3 and rewrite it as x to the power of 6. I'll explain why this works. This expression states that there's 3 of these x squared quantities. So we have x squared, and x squared, and all these are being multiplied together. And then each one of these holds 2 x's being multiplied together. And if we count that up, there's 6 x's. So 6 x's being multiplied together is x to the power of 6. Lastly, I wanted to quickly clarify the difference between this and this expression right here, because in the math challenge I posted last time, I understand there was some confusion. So if you don't know, if you want to go check out that math challenge, go check that out. But first, this expression is saying that you first raise x to the power of m, and then you raise that whole result to the power of n. So this, according to the exponent power rule, would be equal to x to the power of m times n. Versus this, we're raising x to the power of m, and that exponent is being raised to another power of n. So you would first need to solve these exponents in order to power that to x. So you would have to solve from top to bottom. So this is saying x m power of n. So you would have to solve this first in order to power that to x. So let's look at a simple example for the difference between these two. Let's have x as 2, m as 3, and n as 2. So for the first expression right here, we have 2 cubed, and then that whole thing squared, which would equal 2 cubed is 8. Because it's in parentheses, we solve that first. It's 8 squared, which equals 64. Or if you're using the exponent power rule, you multiply 3 times 2, so 2 to the power of 6, which is also equal to 64. Okay, now for the second part, the second expression is quite different. 2 cubed and that exponent squared. So you would have to, since 3 is being squared, not this 2, we would have to solve the 3 squared first. 3 squared is 9, so 2 to the power of 9, which equals 512. You can clearly see the difference between this 64 and this 512. Even if you put it into calculators like Mathway or Desmos, there is a difference and it'll tell you the same answer. Make sure it really depends on where you put the parentheses. So in summary, this first expression and this second expression are not the same. This expression simplifies to m times n in the exponent, while this represents x raised to the power of m, which is this m is being raised to the power of this n. So there's a difference in the answers. And also, go check out last week's video if you want a fun challenge.